Algebra 2, we're looking at section 1.2, but we're going to dive into this a little bit more deeper. For each table given, assume that the pattern of growth or decay is constant. They want you to find f of 3. We've got this pattern. Take a look at this table. T, in general, we're going to let this be time. We don't know what f of t is. It's generally like your y coordinate, but y depends on t. Look, we have 2, we have 5, we have 8. Before too long, kids will hopefully notice a pattern. I hope you're seeing that we're adding a 3. We're adding a 3 yet again. You would say, well, if this pattern of growth were to continue, I'd add a 3 one more time, and we'd be up to 11. So 0, 2, that's what this really is saying. That's the point 0, 2. It would look just like that. 1, 5, we'll go 1 to the right, go up 5. 2, 8, we'll go 2 to the right, we'll go up 8. 3 to the right, well, might have to extend that just a little bit, but there you have it. That's going to be your graph. The recursive formula says that if you want to find a current term, you have to go to your previous term and do some work to the previous term. For example, when we just found this answer right here at 11, someone could say, well, add 3. And of course that is true, but the bigger question is, well, add 3 to what? Well, add 3 to the previous term. So for this recursive formula, we're going to say that a y value that we're looking for, f of t, is going to be equal to the previous y value. Here's that t minus 1. If we were looking for a t value of 3, well, we have to go back to 3 minus 1. We have to look at what's happening to the step right before that. And that's what we're going to do. We're going to be adding a 3 to that. Now, of course, it's never enough with this recursive pattern to say this is it. You're going to also have to give a starting setup value. So you'd say f of 0. Well, f of 0 is 2. Now, by the way, this is the step that kids very frequently forget, the initial step. You have to define what you are starting with. Now, the explicit formula, I do want to say this much. One way you could look at that, one way you could look at this explicit formula is if we had a line. And when you were graphing a line, guys, undoubtedly in algebra, the very first thing that you would have been working with would be equations of the form y equals mx plus b. M was your slope. Well, what is your slope? You're going up 3, 1, 2, 3 steps up to the right, 1, 2, 3. Hey, that, by the way, is how you are changing your y value, if you really think about that. Your slope is a 3. But what do we begin with? Well, what do we start with? Here's your y-intercept. It's right here. It's a 2. So normally we'd write 3x plus 2, but I'm going to write 3t plus 2. This is your explicit formula. Look, we know that the next term for 4, we'd just add a 3 if I wanted to find out what f of 4 was, and 11 plus 3 is 14. I do want to just make a side comment. With this explicit formula, you wouldn't even need to look at the table. You know 3 times 4 is 12. 12 plus 2, of course, you'd get 14. You would have gotten that either way. You can get it from the table, or you can use this powerful explicit formula. So let's take a look at number 2. Number 2, we have a pattern of decay. Our numbers are going down. Looks going from 10 to 7. Looks like we're going to subtract a 3. From 7 to 4, subtract a 3. Again, subtract a 3. 4 minus 3, you'll get 1. Well, 0 comma 10, that's way up here. 1 comma 7, that's right over here. 2 comma 4, that's right here. 3 comma 1, that's right over here. And now what? Well, for our recursive formula, we're always going to say f of t is equal to f of t minus 1. This is your current term. This is your previous term. But look, even when we got this last statement right here, a lot of times kids will say subtract 3, but we have to throw in that we're subtracting 3 from the term previous to what we're looking at. We're always going backwards, so this is what we'll have. Guys, once again, you have to start somewhere. You're going to say f of 0 is equal to 10. You need both of these for the recursive formula. For the explicit formula, well, if we look at y equals mx plus b, well, my goodness, we can see this is a 10 up here, and that's going to be our y-intercept, isn't it? Take a look at our slope. We go down 1, 2, 3, and 1 to the right. Wow, here we go again. This is what you really need to make a connection with. Your slope is that change in our y values, isn't it? So we can say, instead of writing mx plus b, we can say mt plus b, so to speak. Here's your slope, negative 3t plus a 10. Hey, look at that one. All right. Well, as we keep going here, just want to make an obvious observation that for number 3, this is way different. We are given a recursive formula. But once again, we need that initial step. F of 0 is 9. Wow, we've got a 9 in there. And look, here's your current term, and here's your previous term. The change is a subtracting of 4. Well, 9 minus 4, you'd get a 5. Subtract a 4 again, you'd get a 1. Subtract a 4 once more, you'd get negative 3. So we'll graph it. 0, 9 is going to be up here. 1 comma 5 is going to be right over here. 2 comma 1 is this way. Now, to graph the next part, we're going to have to go down just a smidge and say it's going to be like so. But once again, let's think about our y-intercept. Your y-intercept, you can see right over here is a 9. What about your slope? Well, you can see you're going down 4, right 1. That's your change. So I'll say f of t is equal to negative 4t plus 9. And that's your explicit formula. For our last one, here we are given the explicit formula. And wow, we're supposed to fill out all the other information. Tell you what, this explicit formula, like I was saying earlier, the power in it is that you can plug in whatever t values you want. You could plug in a 0. Look at this. Anything times 0 goes away, you're just left with a 10. Look at that. What if we plugged in a 1? Well, if we plug in a 1, we'd have negative 3 times a 1 plus 10. Negative 3 plus 10 is 7. And you could keep going. You could say, well, at f of 2, it's negative 3 times 2 plus 10, and that's negative 6 plus 10, and of course you'll get a 4. It doesn't take long, however, for kids to see, hey, I know the change. The change, by the way, the constant change, you're subtracting a 3, and by the way, that's your slope, isn't it? That's your slope. So if you keep subtracting a 3, I think you can see very quickly you're down to a 1. You could have plugged the 3 into that formula to see that was the case. So you've got 0, 10, got 1 comma 7, 2 comma 4, 3 comma 1. There's your line. Recursive. Well, I think you know by now that you're always going to start with this. There's your current term. This is always your previous term, but what kind of change do we see? Well, we are subtracting a 3. But don't forget, just as important, to really represent this pattern, you also have to say what you are starting with. And that is really our additional lesson on 1.2. These 4 concepts are always going to go hand in hand. The table, the graph, the explicit formula, and the recursive formula.